Hello everyone. In previous session, we have seen how to create a doubly linked list and how to display the contents of doubly linked list in both the directions, that is in forward and backward direction. Now in this session, we are going to learn about the insertion operation in doubly linked list. After taking this session, you will be able to explain the insertion operation in doubly linked list. And also you'll be able to create a doubly linked list and insert the new node at any position in doubly linked list. Let's discuss the insertion operation in doubly linked list. This can be done in 4 ways. We can insert a new node at the beginning of the doubly linked list as a first node. We can insert a new node at the end of the list as a last node. We can insert a new node after a given element. You can insert a new node before the given element. Let us look into each option in detail. Insert a new node as a first node. That is, insert a new node at the beginning of the list. Let us consider a doubly linked list with 3 nodes. With the first node, we are referring with the head, and the last node, we are referring with the last. Now, take a new node and insert it before the head node. Now, take a new node and allocate a memory and refer that memory with the name n. Insert the data value as 40 and make the next reference as null and the previous reference as null. Initially, it is not pointing to any other node in the list. Now, you need to attach this node before the head node. Here, the 1000 is the head node earlier. So here, give the forward link between the n and head in such a way that store the address of the head node in the next field of n. Then the forward link will come between n and head. In such a manner, give the previous link in such a way as store the address of n in previous field of head. Now, after doing this connections, now the first node we are referring with n and the second node still we are referring with the head. Now move the head to the first node by doing the assignment as head equal to n. Now see the function. First allocate a memory for the node structure and refer that memory with the name. Insert the data value in arrow data and make the next part as null and previous part as null. Just give the forward link by storing the address of a head in the next field of n. Then give the previous link by storing the address of n in previous field of head. Now move head to first node by doing the assignment head equal to n. Let us discuss the insertion operation for the last element. Let us insert the new node at the end of the list. Consider the same example of doubly linked list with 3 nodes. With the first node, we are referring with the head and the last node with the last name. Now here, the last node we are referring with the name last, where the last next part is null as this is not connected to any other node in the list. Now take a new node n, refer the memory with n, insert the data value, make the next part as null and previous part as null. Now you attach this node at the end of this list. So for that you need to give the links between the last and n. Then the forward link can be given by holding the address of n in the next part of last. Similarly, you give the previous link by storing the address of last in the previous part of n. Now, after doing this kind of the connections, now this node is referring with last and the last node we are referring with n. But we know that the last node must always be referred by last. Hence, you need to move the last from this position to this position by doing the assignment last equal to n. Now see the implementation. Just allocate memory for the node structure, insert the data value and make the next part as null, the previous part as null. Now we are ready with the new node. Attach this node at the end of the list just by giving the forward link, holding the address of n in the next part of last, and then give the previous link by storing the address of last in the previous part of n. Now move the last to new node. This is about the insertion at the end of the list. Now coming to the insertion after a given element. Let's see the scenario. Again, take the example of a doubly linked list with the 3 nodes. With the first node, as usual, we are referring with the head, and the last node with last. Now take an example of insert a new node after 20. Here I am taking an example. I am trying to insert a new node after this 20. Now, what I'll do is just I'll allocate memory for a node, and I'm taking the data value as 50 and making the next as null and previous as null. And this node I'm referring with the name n. Now, what I'll do is I want to insert this after the element 20. So for that, you need to make a search for the element 20 starting from the first node. Here, the first node is head. Okay, so from here, I'll try to search for the element 20 that I can do by using a temporary pointer. Now, the temp is pointing to head, then the temp arrow data is 10. Now, the 10 is not equal to 20, that is not our desired key. Then I'll make a move of temp to the next location. Now the temp arrow next will move the temp from 1000 to 2000. Now the temp is referring to the memory 2000. Here what is temp arrow data? The temp arrow data is 20. That is the key which I am searching for. Then here I'll stop moving the temporary pointer. So the name of this location is 2000. The name of 3000 is this address I am storing in the next part of temp. Hence, the name of 3000 is temp arrow next. Now, we are clear with the names of the nodes, as this node is 2000, which is temp. This node is 3000, located at 3000. The name is temp arrow next, and this node is n. Now, give links between these 3 nodes. First, give the forward link between n and temp arrow next, simply by storing the address of temp arrow next in the next field of n. Just by taking the assignment n arrow next equal to temp arrow next. Now give previous links between n and temp arrow next, simply by storing the address of n in previous part of temp arrow next. The temp arrow next arrow previous. The name of this part is temp arrow next arrow previous is storing the address of n. Similarly, you give the left side links between the temp and n. Just temp arrow next is storing the address of n. So this link will establish just by simply writing the assignment temp arrow next equal to n. Now, similarly, you give the previous link like n arrow previous is holding the address of temp. N arrow previous equal to temp. Like this, we'll insert a new node after the given element. Let's see the function for inserting a new node after the given element. Allocate a memory for the node structure, insert the data value, make the next part as null and previous part as null. Read a key which you want to, which you want to make the insertion after that element. Now start searching for the key from the first node just by doing the assignment temp equal to head. Now till you reach end of the list, you need to search for the given key. If temp arrow data equal to key, then you stop searching for the key, or otherwise move temp to next node to make this search. Now, give the forward links, right side forward links, n arrow next equal to temp arrow next. The previous links, temp arrow next arrow previous equal to n. The left side links, temp arrow next equal to n and n arrow previous equal to temp. This is the implementation of inserting a new node after a given element. Let us discuss insert a new node before the given element. Take the same example of doubly linked list with the 3 nodes. With the first node, as usual, referring with the name head, the last node with the name last. Now insert a new node before the element 30. Just create a new node and refer that node with the name n. The data here I am assigning with 50. The next part is null and the previous part is null. Now here you need to make this search for the element 30 because you need to insert a new node before 30. Now that kind of the searching will happen again starting from the first node. The first node we know that we are referring with the name head. So that what I'll do is that I'll store into the temporary variable. The temporary pointer is referring to the first node which is already referred by the name head. Now, check for the data. The temp arrow data is 10, which is not equal to 30. So what I'll do is I'll store this temp in another point, the previous one, and I'll move temp to next. Now, what is temp arrow data? Now, the temp arrow data is 20, which is not equal to 30. Then again, what I'll do is I'll move temp from this location to this location. Now, whenever I'm making a move of temp to the next location, I'll store the temporary information into the variable previous one. Now, here, what is the temp arrow data? The temp arrow data is 30, which you are searching for. Then you stop searching for, then you stop moving the temporary pointer. Now, here, you give links between the previous one, temp, and now give right side link, like store the address of temp into the next field of n. This we can do this simply n arrow next equal to temp. Similarly, you give the previous links like temp arrow previous equal to n. Like give the left side links as n arrow previous equal to previous one and previous arrow next. This is called as previous one arrow next equal to n. So this is the procedure to insert a new node before the given element. Let's see the function. This is not after, it is before. Allocate a memory for the node structure, insert the data value, make the next part as null, the previous part as null, read the key before which you want to make the insertion. Start searching for the key element from the first node, temp equal to head, till you reach end of the list. Search for the key element. If you found, then you come out of the file. Otherwise, store the temp pointer in previous one and move temp to next node. Now, afterward, give the right side links just by storing the temp arrow next address in the next field of n and n address into the previous field of temp arrow next. Similarly, the right side links the n address into the next field of previous one and the previous one address into the previous field of n. So this is the procedure to insert a new node before the given element. Let us implement the insertion operation in doubly linked list using C. In previous program, we already defined the creation and display functions. Now let us declare the functions for insertion. Void insert begin, void insert last or insert end, void insert after, to insert after a given element, and another declaration insert before. I include these into the menu options. The fourth option is insert begin. The fifth one is insert end. Then 6 is insert after. Then 7 is insert before. Let's define each function. We'll append function calls here within switch case. Case 4, insert begin. And then case 5, the function call to insert int. And then case 6, insert after. Then case 7, insert before. So these are the function calls. Iterate for all the options. Now we'll define each function. Insert begin. Here, allocate a memory. Read the data value. Make the first and last next and previous pointers as a null. And then hold the address of head in the next part of n. This is the way to give the forward pointer. And the head previous should store the address of n. This is the previous pointer, and move head to n. Head equal to n. Now similarly you do for the end. Insert n, and here last arrow next should store the address of n, and n previous stores the address of last, and move last to n. Then the next one is insert after. Now here you need to read for the element. Printf enter entered value, after which you want to insert. Now read that key that I am taking as key. Declare that key variable before using it. Int key. Now start searching for that key. Temp equal to head. Then while temp not equal to null, if temp arrow data, if temp data is equal to key, then you can come out of the loop. Just to give break. Otherwise, you need to move temp to next node. Now give the left pointers and first give the right pointers. N arrow next equal to temp arrow next. Then temp arrow, this is for the previous link. Temp arrow next arrow previous is equal to n. Similarly, the right side links. Temp arrow next equal to n, and n arrow next, n arrow previous equal to temp. Now write the insert before. Here required another pointer to store the address of previous node. Struct node star previous one. Instead of after, here this is before. Now before moving to the next node, store temp into previous. Now here n arrow next equal to temp arrow previous equal to n, and previous one arrow next equal to n, the left side links, n arrow previous equal to previous one. These are the definitions for insertion operations. Let's see the execution. First, create doubly linked list with 5 nodes, giving the data values 10 to 50, 30, 40, and then 50. Print the contents of doubly linked list. So these are the data values which are there within the doubly linked list. Let's implement the insertion operation one by one. Give the choice as 4, which inserts the new node at the beginning of the list. So it is asking to enter the data. I am giving 60. Now see the execution. Let's see here. The 60 got inserted into the list as the first element. Now see the implementation for insert at the end. Now give the data value, for example 70. Now see the execution. The 70 got inserted at the end of the list. Let's execute insert after. The choice is 6. Now here I am taking the data value, for example 80, and I want to insert it after 30. Now just run it. See here. So this element 80 is inserted after 30. Now the last choice, that is 7, to insert a data value before the given element. For example, I am giving the data value as something like 90. And before 40, I want to insert this 90. Let's see the output. See here, the 90 got inserted before 40. So this is an implementation of insertion operation in doubly linked list.